So now let's make a chart with the data that we have in that feature collection that shows us the relationship of the properties of each island with respect to area and distance. So I'm going to copy this and go over here. I've basically given you the script, but that doesn't mean it's necessarily going to work. So what I'm going to do at the top of this is make sure to say print out all islands first, so that if you get errors here, I can point you to maybe some of the reasons for that. So this will run, and the chart will be clicking out here. But the idea is that I am creating a chart from the All Islands feature collection that we just looked at. I'm sorting it on land, but that was kind of a failed effort, because what I was annoyed that I couldn't get these to go 1, 2, 3, which would be a lot more sensible to me. But what this chart should look like is that the gray dots represent the area and distance of the Pleistocene islands. The blue dots represent the area and distance of the oceanic islands. And these kind of tan gold, um, uh, the tan, I don't know, the land looking um, dots represent the continental islands that were connected to the mainland. And so if it totally won't draw, let's just kind of look through this. The features is drawing from the All Islands feature collection. The X property, which is this axis, is drawing from the distance. And so if your property here is not named distance kilometer, you're going to be in trouble. So where did distance kilometers come from? And if you did not set your the name of your distance in 1.5 to distance kilometer, that's probably where this went wrong. Is that fair? So that was a kind of a key step. Um, Area square kilometers, similarly. I'm just gonna, first of all, did you guys see how I'm sorry, I just did Control F anywhere here to get this little search thing. And if I'm saying area, uh, what am I after here? Area underscore square kilometers, where did that come from? Well, that came from step 1.3 when I had you rename the pixel area square kilometers. And if you did not do that, then I had you sort it there, and then I had you filter it there, and then it's coming into play here. So that step's kind of important early on. We're drawing on it here. Um, and the land series properties, land, we've talked about that. That's how you're getting these different color codes to represent the different historical classes. The rest of this should work pretty clearly as long as you just have 1, 2, and 3, as long as that last kind of little check I did with the aggregate array, as long as you just have 3 values here and you have 3 colors, it should work fine, and it should print it out. Okay, so then what you get here is the ability to look at a couple of things. One, to realize that the island, Santa Rosa, I think is that one, is much larger than the modern islands. This island is also much larger. Even this one, the Ice Age islands were bigger, or there were more. There were a few much larger Ice Age islands than the islands that we have today. You can see that this island was not only big, but it was very close to the mainland. So you'd expect the biodiversity of Santa Rosa to be relatively high. A lot of native species on this island before it became the 4 northern islands. Is that fair? And then you have your oceanic islands here. So this one here is going to be your largest one. That is also kind of close to the mainland, if that makes sense. This one is a little bit smaller, a little bit further, and that's kind of how you read it. But what's a little bit problem right now is that you just have the class and you get 2 numbers here. It's an X and a Y. So the X is going to represent the kilometers and the Y is going to represent the area, right? X is distance, Y is area in this kind of format. So what would be nice would be to come up with a way to be able to hover on this get some information about, and then about this island, but then actually be able to find that island here. So that's the final step, I think, in the tutorial.